Engine Performance 2 Test 9. Technician A says a pickup coil / pulse generator can be tested with an ohmmeter. Technician B says ignition coils can be tested with an ohmmeter. What do you think about that? You know what a pickup coil is, right? Look in that distributor. See that distributor right up there? It's got that rusty vacuum advance on it right there. See that right there? Right there. That's got a pickup coil in it. It's basically a little coil with a magnet around it. It's got 2 wires coming out of it and a little magnet that the wire's wrapped around. Every time one of those, if there's an 8-cylinder, it'll have 8 little points on that reluctor that goes past that thing. And as the magnetic field shifts back and forth, it creates a sine wave. And that sine wave is what the ignition module uses to make the decision to fire the coil. Now, because of the relationship between the outside of that distributor and that center pickup coil is going to have to do with your timing. That's why you can turn the distributor and set the timing on those, just like you can on this other one up here. Has got points, and those points open and close based on 8 little bumps, you know, or 6 or 4, you know. But one way or another, both of those guys are right. You can hook an ohmmeter to both sides of that pickup coil, you know, 400 to 800 ohms on some of them, you know, 1,000 to 1,500, whatever, on some others. You can also check an ignition coil with an ohmmeter. Like on one of these coils like that one right there, if you see that one here, and I grabbed the wrong pointer, that one right there, that E-core ignition coil, supposed to have about 3 ohms, and on that particular one, if it's got 2 ohms, it probably won't fire. You can also check those over there with an ohmmeter, that kind of like that. And so all of those can be checked with an ohmmeter. Checking an ignition module with an ohmmeter, not so much. But there are things that can be wrong with a pickup coil, like it can get hot and open up and cause the engine to stall. Or the ignition coil can get hot, you know, and not make as strong of a spark or something like that. But typically, checking it with an ohmmeter is something you can do. Finally, let's see, Technician A says, so this is number 2, that a defective spark plug wire can cause an engine misfire. Now that's a no-brainer, isn't it? Anybody knows that a spark plug wire. Let me ask you this though, while I'm here, how do you know you got a bad spark plug wire? I mean, you got to you got to have some sort of an acid test to condemn that, you know. How are you going to condemn the plug wire? Anybody know? I'm going to pull that thing. Well, to begin with, externally you can look at it and see what it looks like. If it's breached anywhere, if it's been laid on a manifold, if the boot's ripped or something like that. I've never covered this with you guys in detail like this. Secondly, another way it can happen is on the inside of it, it's got this carbon core, right? And if that carbon core is, like for instance, every now and then somebody will pull the end off of a spark plug wire and they put it back together, you'll see this carbon core coming out of this wire like this, right? And that's what the wire looks like. Now when you put that terminal back on there, you know, you can actually put the terminal back on there usually. Now some of the wires now are made in such a screwy way it's hard to fix them. But if you're putting the terminal back on there and you're pinching it around that wire, you want to take this and you want to fold it around like that right there. And then you're going to crimp your terminal over it like that. If you don't do that, it's going to start burning this thing up and it's going to burn off up into the wire. So you'll have a wire that you have fixed with it. You've put your metal part back on it, it snaps onto the plug and all that. But at this core, if it's just sticking out here, every time a spark jumps, it's going to burn it up a little bit. It's going to burn way off up in the wire, and you'll just see a little place right here that's got a bunch of carbon around it. And then it's going to have increased more and more and more resistance. Now, that's one way. If you look in the tips of a plug wire, like if you unplug it and you look in both ends of it, and it looks nice and clean in there, you probably don't have an issue like this, right? I've never seen one like this unless when you looked in there, it either looks rusty or it looks scorched and burned, or there's going to be something that doesn't look right looking into that plug wire. Thirdly, you can have a breach in the boot. If the spark plugs have increased resistance because they're old and rounded to the point to where that spark's looking for a place to go and it breaches that boot and jumps out the side, How do you find that? Well, it may not jump out the side until you load it a little bit. Like you're driving about 45 miles an hour, torque converter locked up in 4th gear, pulling up a grade, you'll feel it going boop, 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 boop. You'll feel these coil on plug coils dying the same way. And this, now, I got another little brief thing here. You can take 409 or some water with a little bit of salt in it or something like that, that's got not less surface tension than regular water. And with the engine running, if you've got one with plug wires on it, you can squirt soapy water on those spark plug wires. Now you may see some little orange fire popping around. Don't pay any attention to that. What you're going to pay attention to is if you shoot a little soapy water on one and the engine starts missing and you see it going pop, 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 pop. That means that spark plug wire is junk. But you typically need to look at those spark plugs too. Now here's another thing, like on the Bronco out there. You can actually, we can test this, I can show it to you if you want me to. You can hook up to the negative side of the battery, and you can go to the side of the coil where it's getting its signal of fire. And you're going to get a flickering signal, which is your tack signal, which is the signal that the module sends in to fire the coil. Now, if it's got a nice even flicker like that, then you're just fine. But if you see it going boom, 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 then you've got one of these burned out wires like I'm talking about. You can pull a wire off and see what I'm talking about. It's called a poor man's scope. You got a test light, you can find an open plug wire if you know what you're looking for. Something else I used to do, I'd get a regular old low impedance test light whenever I was working on a lot of vehicles that had coils. And you know, I'm talking about the E-core coils like on the Fords in the late 80s, early 90s. And I would take that thing and hook it into that, like I'm talking about, I'm letting it flicker with the tack signal, and I'd snap the throttle, and if I snapped the throttle with that test light hooked up and it fell on its face, I'd know it needed spark plugs. I don't know anybody else that ever did it that way, but if you snap the throttle and it doesn't stumble, then the spark plugs are nice and healthy. A spark tester should be used to check for spark. Why? Can it detect a cracked spark plug? No. Is it connected to the crank position sensor? No. Can it detect the gap of the spark plugs? No. But it does require at least 25,000 volts to fire. And I think that one that we and Adam figured out that 626 he's working on, the ignition coil is only able to produce about half the energy it's supposed to, at least from looking at that spark. Typical primary coil, incidentally number 3 is B, first 2 are C. Number 4, typical primary coil resistance specifications usually range from what to what. Now primary is actually going to be a lot lower reading than secondary, right?
30,000.
No, this particular one's it's going to be a lower reading. Primary is going to be like half an ohm to 3 ohms. Now, like I told I was talking about earlier, if it's 0.3 ohms on one of those E-core coils, I have seen them where they read just fine at 0.3, but if they drop back to 0.2, then that was not a good coil. All right, let me see here. So it's 0.5, and that's the primary is the one that's triggered. Anytime you're wanting to see if you've got, and I need to go through that board with you guys because it doesn't take but about 10 minutes, and it teaches you all about ignition systems. But the wire that's coming to the negative side, you see on that coil over there, that blue one on the board, you got, and I like being able to point this out with my laser, you got the center post that goes out to your distributor, right, like on this one here. All right, that one there's your secondary. These 2 little ones, they're your primary. One of them, it's going to go from battery plus through this ballast resistor into the hot side of that coil, and then the points on that old points distributor on the far left of the board, they're going to make and break that, saturates the coil. Every time it breaks, that saturation sweeps over those secondary windings because there's a lot more of them. You get a hot spark coming out of here, right, out of the center of that thing. So the secondary, whether you're talking about a relay or ignition coil, is where the work is being done. And the primary is what's triggering the secondary to do the work. Just always remember that's my basic rule of thumb. A typical secondary coil resistance specifications usually range from, and that's your 6 to 30,000 range.
That's what I was talking about.
Yeah. The primary is 0.5 to 3. Secondary is 6 to 30,000. So you're going to see more. The reason for that is the wire in an ignition coil, if you can get it out of there, and you got to be careful in those oil field coils because that oil that's in there is really, really, really poison. But those windings in that thing, if you ever unspooled it, the thread is such a tiny, it's smaller than the thread you sew a button back on with. It's copper wire, and it will have like 1,000,000 windings or something. The more windings you got in the secondary, the stronger the spark is that's generated. Of course, you're trading, you know, volts and amps for, 12 volts for a whole lot more. You're reducing amps but increasing voltage. Because you got to punch across that air gap. Okay, now we got a coil's being tested using current ramping. Okay, now current ramping is when you take your oscilloscope and you take the little current ramp probe, you know, that clips around the wire, and you clip it around the wire that's triggering the coil. Or you can actually go around either one of them, but I like to go around the one that's triggering the coil. And you're going to get a current ramp pattern on the screen. And there's Tammy. Let me see what she wants. Hey, Tammy. Oh, she actually told me just to print that second sheet. She's already got the top one. That was Darlene, and I was sending some corrections over there to last month's requisition. That's why you've only got the bottom sheet. The top one didn't change, see. But all right. Yeah, she was confused about that. Okay, now then, so what the waveform should look like is, what do you think? Start off flat, then slope upward, right? What they're talking about there, basically, is as it builds up, and then it's going to flatten out, right? Then it's going to come down. This is current right here, building up. And the module is going to limit it, because when it gets totally saturated, then it doesn't need to keep feeding current in there. So the module is going to eliminate it to a certain amount of amperage. But you're going to see a current ramp that looks like that. Camshaft, as a matter of fact, it would be good for you guys to current ramp some coils just to see what they look like. You know, you need to be familiar with that. Camshaft variation as displayed on a scan tool on an engine with a distributor mounted cam position sensor should be plus or minus 2 degrees. Now, one of the things that on these CSFI engines, like we've got on that college truck and all, they've got a distributor on there, but you cannot set the timing by turning the distributor on that one, because it's got a crank sensor that's reading somewhere else. The only way you can change the timing on a vehicle with a crank sensor is change the relationship between the crank sensor and the pulse wheel that's being triggered off of. If you turn the distributor, you're just changing rotor alignment, and you're resetting the cam sensor. And one of the things that ticked me off, one of the scan tools, one of the earlier ones I had here that I've updated fairly regularly up to a point, it was that OTC Genesis, and it used to have the cam retard offset for the CSFI truck. So when you pull the manifold off, you pull the distributor out, you put the distributor back in. If you've got an adjustable distributor, and sometimes they got one where you can turn it, sometimes they're locked where you can't turn them. You're supposed to adjust it to 0 when it's over 1,000 RPM, looking at the scan tool. So you look at the scan tool, over 1,000 RPM, cam retard offset, supposed to be turn the distributor until it's 0, lock it down. That Genesis tool, unless they've changed it with some other updates, which I hadn't bought the newest update since they took cam retard offset away from me, and that's only on the Chevy pickups with the CSFI fuel system. I went in there looking for it because I was going to set one, and it wasn't there anymore. Furthermore, I'm going to tell you something else. It's hard to find it in the book. It's hard to find it in the shop manual. So basically 2 degrees, so number 7 is basically going to be B. The spark plug threads in the cylinder head should be cleaned using what before installing new plugs? Although I will tell you, nobody does this. And thread chaser.
Got something I can take her back?
Huh?
Take her back. You're going to be working on her Honda. I need something to drive her back to the library.
Oh, just drive her back on her Honda.
Oh, okay.
Yeah, that'll work. He's coming in here next semester. I've seen him in here before. That's Daniel Gonzalez. He doesn't speak Spanish, although he looks like he would. And you know what happened? I'm serious. And he knows, he'll be the first one to tell you. His name is Daniel Gonzalez. He looks Hispanic, but he could not get a job at this one place he went to apply because he didn't speak Spanish. They were going to hire him. They were all excited about putting him to work. And then they found out that he doesn't speak Spanish, and so he didn't get the job. Is that messed up or what? You see what I'm saying? I mean, he told me that. He says they thought I spoke Spanish because I look Spanish and I got a name that's Spanish. and all that. But anyway, I thought that was crazy. I mean, I'm not trying to get ethnic on you here, but the point is, if somebody can't get a job because they can't speak Spanish, that's messed up. I mean, he would have done him a good job, but they wouldn't hire him because he couldn't speak Spanish. See, they didn't ask him that until they, when they finally did. All right, thread chaser. What's the problem there? Somebody tell me what a problem is with that. I don't like that. What happens when you run a thread chaser down there? What is a thread chaser? It kind of look. Huh?
You might get metal shavings in the cylinder.
Bingo! Listen to him. Anything you chase out of those threads is going to fall in the cylinder. But now occasionally you've got to run a thread tap down in them spark plug threads. How do you do that without causing? You've got to do it. We're going to pull the head off? No, I'm not going to if I can get out of it. What do we do? Anybody done that here since I've do it? We do it fairly regularly, but what do you do if you have to? What if you find yourself in a position where some yo-yo that worked on it at a different place or whatever only screwed the spark plug down in their part of the way, and then it blew out of there, and now the threads are messed up somewhat, and you can get a new plug in there, but you're going to have to run a 14 millimeter thread tap down in there. So what are you going to do to keep that stuff from falling in the cylinder? I want you to use your pumpkin. Critical thinking is the key here. We've done it here repeatedly a lot of times. You can do it safely without letting stuff get down in the cylinder. My dad showed me. My dad's always been a critical thinker, man. He can come up with an answer of how to do something. And it's just, I mean, it's fairly common. All you got to do is take your air hose and tie wrap the thing where it's blowing really hard all the time. Stick it in the throttle body. You got your spark plug out of the hole, right? Turn the engine over by hand until air starts going. Intake valves open, you're blowing air out the spark plug hole. The whole time you're working, you're blowing air out the spark plug hole. As soon as you start tapping that, every little piece that comes off is going to come back out. It's not going down in there. Got me? You'd be surprised what a tiny little something you can get in that cylinder and crank it up and you'll hear it knocking. And that's dreadful. So what we want to do, everybody remember that? Start air blowing in there. Turn it over so there's air coming out of the spark plug hole. Run your tap in there. Not complicated, not hard to do. You don't have to know anything about top dead center. All you got to do is turn the engine until air starts coming out that hole. But you got to have air going in there. Everybody get anything out of that? All right. Two technicians are discussing a no start condition during cranking. A magnet held over the coil moves and the engine backfires at times. That's interesting. Technician A says a bad pickup coil or crank position sensor is most likely cause. Technician B says an open coil primary is the most likely cause. Who's right about that? Neither one of those guys. Now, I never have dangled a magnet over a coil, myself. I mean, that's not anything I'm particularly excited about doing because I got so many other ways that I check one. Which sensor produces a digital signal? Magnetic sensor, Hall effect sensor, pickup coil, or both B and C? Only B. We talked about Hall effect sensors the other day. All right, we're still, we got a little time here. Technician A says a thorough visual inspection should be performed on all ignition components when diagnosing an engine performance problem. That is true. Technician B says platinum spark plugs can be regapped after use in an engine. Now that's Technician A only. Technically you're not supposed to regap platinum spark plugs, but every mechanic that I know of at some time or another has probably regapped a platinum spark plug. I don't know why that's even a big deal, but they always say you're not supposed to regap them. There's no point in it really because the platinum doesn't wear off kind of near as bad as a regular copper spark plug or whatever it is. Technician A says the slope of the spark line can indicate excessive exhaust gas recirculation whenever you're using the oscilloscope pattern. Like Adam and I was checking that 626 oscilloscope yesterday. Technician B says secondary ignition scope pattern includes a firing line, spark line, intermediate oscillations, transistor on and off points. Who's correct about that? That's B. You can't tell by looking at the spark line if you got excessive exhaust gas. But I will tell you something you can tell from the spark line if you know how to look at it. You can tell if you got a rounded off camshaft lobe by looking at your spark line. That sounds peculiar, but there's a way to do it if you know how to read it. Let's see. Let me see. Which of these components sends a pulse signal to an electronic ignition module? Pickup coil, coil wire, resistor, or ignition coil?
Pickup coil?
Yep. Good answer. Technician A says indexing the distributor is the same as setting ignition timing. Is he right? Technician B says the distributor is not phased correctly can cause a misfire and rough idle. Now, everybody knows, everybody that's done any working. I've got to get those lifters pumped up on that GM engine out there, that 350, because I like for everybody to be able to find top dead center, put a distributor in there, put the plug wires on. I mean, that's one of the reasons I keep that old engine around. One of a few. But the simple fact is, if you've got a distributor out of one, whether it has a crank sensor or not, you got to have it so that your number one, your rotor's pointing right about number one whenever you're on top dead center compression. But the indexing of the distributor means the body of the distributor has got to be pointing the right direction. Now, what do you notice about the difference between those first two distributors on that board up there? You notice on that Chevrolet distributor that's on the left, that vacuum advance is coming off on the left side, and on that Ford distributor, which is also another V8 about the same size, the vacuum advance is coming off on the right side. What does that mean? All right, I'm going to tell you what it means because I'm getting blank looks. It means those two distributors on the vehicle turn in opposite directions. The one on that Ford turns counterclockwise and one on that Chevy turns clockwise. If you look at the way the vacuum advance comes off of it, you can typically tell. All right. Now then, let's look at this thing right here, technician. Wait a minute. So 14 is actually B because indexing the distributor is not the same thing as setting ignition timing. A diagnostic trouble code P0301, which would be a misfire on cylinder number 1 on a waste spark system, could be caused by any except what? Could it be caused by a defective plug connector, open plug wire on cylinder 1, defective pickup coil, open spark plug wire on cylinder 4? What do you think?
D.
Okay, any of them except, okay?
Oh.
Except. Look at the except. Could a pickup coil cause it to misfire on that one? Now, I did tell you guys a story about a tempo that, didn't have the signature pip blade window in it, and it was causing it to misfire on cylinder number 3 when you'd crack the throttle. So I don't think the guy that wrote this test ever run into that, but that one there is basically supposed to be, you see, a defective pickup coil won't cause it to misfire on that one cylinder. Now, if you've got a tooth broke off your reluctor, it might. The little star wheel that spins around next to the pickup coil. If you got a tooth broke off that, you may have a problem like that. A no-start condition on an engine equipped with a waste spark ignition system is being discussed. Technician A says a bad crank position sensor could be the cause. Technician B says an open spark plug wire could be the cause.
Yeah, both.
That's going to be the crank position sensor. An open spark plug wire is not going to keep an engine from starting. Technician A says a defective crank position sensor can cause a no spark. Technician B says a faulty ignition control module can cause no spark. Both of those guys, that's not rocket science there. Didn't even have to talk about that one very much. What is this testing device here? I've got one of these, but it doesn't look like the ones we use around here. That's a spark tester. Looks like a spark plug, but it's a spark tester. And it takes a pretty good bit to fire that spark tester too, like 50,000 volts or something. When diagnosing an electronic distributor ignition system, a 12-volt test light is connected from the negative primary coil terminal to ground, flutters while cranking the engine. A test spark tester does not fire when it's connected from the coil secondary wire to ground while cranking the engine. Now, one important distinction here is don't have your test light hooked up while you're checking for spark because you may not see any spark. Have your test light disconnected when you're checking for spark. If you're getting a flutter, though, it basically means the coil is being told to fire. And I'm not talking about the little ripple that you're getting from the from the spinning of the starter and the amp bump. I'm talking about you see a little pulsing signal coming to the primary side of the coil on the negative side. That means the electronic module is telling it to fire. Okay, the cause of this problem could be, that's going to be basically ignition coil. If you're getting a flutter, you know your module's working, you know your pickup coil's working. Now, here's something else. You got to make sure when you're checking for spark that you let that thing jump far enough to scare the daylights out of you. I want it to jump about an inch, and I want it to be bright blue, and I want it to make loud popping like noises like Frankenstein's, and all this stuff. I want to see that. And I have seen some of the old textbooks would say, hold the spark plug wire 1/4 of an inch and let it jump 1/4 of an inch, and then that's how you tell if you got spark. Well, their rationale is if you let it jump too far, you may have it may backfeed and mess something up. But I'm gonna tell you, if it doesn't jump good and strong, I had a Taurus one time that was a hard starter, and it would whoa, 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 and it would finally start and run pretty good once it got started. But boy, that thing would spin and spin and spin and spin. It had good fuel pressure and all that. And the coil was not strong enough to jump the spark more than about 3/4 of an inch. Beyond that, it wouldn't jump. I put a new coil on there, and it would fire right up. So, you know, it's a little hard for it to start. Anybody driven a Model T in here so you know how to start that one with the crank? You had never done that? You've actually got a lever on the steering wheel that retards the ignition timing. So when you start it with the crank, you get out in front of it, you turn the crank on the engine, you fire it up, and then you advance the ignition timing and you got good power to drive away. But you actually would retard the ignition timing to start it. There's a lever in the middle of the steering wheel that you move it back. And if you didn't do that, if you tried to start it without moving that lever, that thing would kick back and it'd break your arm. And that can ruin your whole day, right? All right then. Well, there was a guy that was working on one of those, working on the carburetor on the Lincoln Mercury, believe it. They came in on a trailer, green Model A Ford pickup, old, you know, Bunny and Clyde looking thing. And I told him he was trying to start it and he couldn't get it to start. I said, you're going to have to retard that timing, Bobby, before it's going to start. You know, and because I don't even remember where I learned that, but that's something you got to do. Okay, let me see. Where are we at here? Let's see, the vehicle with an electronic ignition system's got a loss of power with no engine misfiring. Technician A says the base ignition timing may be late. Technician B says exhaust system may be restricted. Who's right about that? B. So basically you're not going to have you know, loss of power with no engine misfiring. You can't have ignition timing set. However, I will tell you this, if that keyway's wallered out on that crank wheel down there, that little wheel with the teeth on it, and it's moving around, you're going to have retarded timing because of that if it moves the wrong direction. Let me see, distributor ignition system has a Hall effect type pickup trigger. Technician A says this type of pickup may be tested with an ohmmeter. You can't do that. Technician B says this type of pickup produces an analog voltage signal. Both those guys are yo-yos. And finally, number 22, the pickup coil can also be tested for proper voltage output. You can hook it up with your AC meter and you can find out what the voltage output is, or your scope, and look at the amplitude. And during cranking, most pickup coils should produce a minimum of how many volts? Should be 1/4 of a volt AC, but I like to see more than that, to tell you the truth. Because if it's too weak, you're not going to get any spark popping.
1, 7, and 8.
Huh?
1, 7, and 8.
Well, you missed one and you were sitting here. All right. Somebody tell him what one was. You can test them with an ohmmeter. Both of those are true. And 2 degrees is that one. And use a thread chaser on. You got caught up in the story, didn't you? All right. Anybody got any questions about that?